Here we are in the constellation Andromeda, or at least a model of it, next to the constellation Perseus. Andromeda, in the Greek myth, was the maiden who was saved by Perseus from a sea monster. This star just above me is Beta Andromedae, the second brightest star in the constellation, 75 light years from the Earth. The light by which we see this star has spent 75 years traversing interstellar space on its journey to the Earth. In the unlikely event that Beta Andromedae blew itself up a week ago Tuesday, we will not know of it for another 75 years, as this interesting information, traveling at the speed of light, crosses the enormous interstellar distances. When the light we see from this star set out on its long interstellar voyage, the young Albert Einstein, working as a Swiss patent clerk, had just published his epical special theory of relativity here on Earth. We see that space and time are intertwined. We cannot look out into space without looking back into time. The speed of light is very fast, but space is very empty, and the stars are very far apart. In fact, the distances that we've been talking about up to now are very small by the usual astronomical standards. In fact, the distance from the Earth to the center of the Milky Way galaxy is 30,000 light years. From our galaxy to the nearest spiral galaxy like our own, called M31, and which is also within, that means behind, the constellation Andromeda, is 2 million light years. When the light we see today from M31 left on its journey for Earth, there were no human beings on the Earth, although our ancestors were nicely evolving and very rapidly to our present form. There are much greater distances in astronomy. The distance from the Earth to the most distant quasars is 8 or 10 billion light years. We see them as they were before the Earth itself accumulated, before the Milky Way galaxy was formed. The fastest space vehicles ever launched by the human species are the Voyager spacecraft. They are traveling so fast that it's only 10,000 times slower than the speed of light. The Voyager spacecraft will take 40,000 years to go the distance to the nearest stars, and they're not even headed towards the nearest stars. But is there a method by which we could travel in a conveniently short time to the stars? Can we travel close to the speed of light? And what's magic about the speed of light? Can't we travel faster than that? It turns out that there is something very strange about the speed of light, something that provides the key to our understanding of time and space.